are now live online. I can see those of who you just joined us. It looks like we have a bunch of people joining right now. Welcome, welcome, welcome to the Wagon Tokyo workshop. We're thrilled to have Dia with us today, delivering her third workshop, I believe. Oh, second one, sorry. This time it's a creative coding with JavaScript part 2, and generative art. And now it's get right to it. I will hand it over to Dia. And also, this session will be recorded. Yes.
Thank you very much. Sorry, can you confirm you can see me and hear me okay?
Yes.
Okay, perfect. Hi, everyone. Thank you so much for coming. I really appreciate you taking the time for this. And my name is Dea, and today I'm going to be talking to you about creative coding and using JavaScript and P5. I'm going to share my screen now, and okay, and you should see my screen has a presentation. So let me know if you don't see that. And also, can I ask Thierry if you can please share the link to this presentation now? That would be great. And I'm going to cover quite a lot of material, so please feel free to type any questions in the chat as I go. And then I'm going to have some stops when you can unmute yourself if you want to, or you can write some questions. It's a small group today, so we can be as interactive as you want. If you have any questions, don't worry about asking them. If you think that they're too basic or anything, they're not. We have enough time to go through that. So without further ado, this is the second part of my creative coding with JavaScript workshop. And if any of you were here last time we talked about HTML Canvas and GSAP for animation. And today we're going to be talking about p5.js. And hopefully, I'm really hoping that some of you already have a little bit of knowledge or experience using Canvas or using JavaScript for creative coding in some other way. But I'm going to try to give a little bit of a revision as well. But we're going to spend more than an hour today just on hands-on coding and learning p5.js. We're going to learn the basics of it, then we're going to learn a bit about randomness, a bit about Perlin noise, and how these things can then be used to start generating your generative art using p5.js. I'm going to try to complete a generative sketch, and I'm going to show you now what it looks like. So this is going to be our final project, and we'll do our best to go through everything and to get to the point where we can do this together from zero to this. If we run out of time, I might need to do this a little bit quicker, but you can always ask me questions, and you can ask me questions after the workshop as well. So very quickly about me, my name is Dea, and I've been working as a data visualization developer at Reuters in London. And before that, I lived in Tokyo for a couple of years. I did data visualization at the University of Tokyo. And I've been working with data visualization for about 3 or 4 years. Before that, I did some machine learning and some data science. And I'm really interested in data visualization, data art, and generative art, and creative coding. So a lot of these things have to do with visually representing information, whether it is with data visualization, where it's a bit more practical, or it's data art, where it's a bit more creative, or it's just creative coding, where it doesn't need to have a purpose, it's just more of a creative expression. And this is what I'd like to talk to you about today. I showed this slide last time, for those of you who are here, but when it comes to creative coding, there are many options that you have, and there is even not a single definition of what creative coding even means. But what we're going to mean for the purposes of what we're focusing on today, creative coding with JavaScript, we basically mean either data art, generative art, or creative storytelling. So anything where you use code, specifically JavaScript in our case, in order to have something appear on the screen which looks like visualization or art or some kind of storytelling. So some kind of creative visual expression, which is entirely or almost entirely done using code and not, for example, through a drawing program like Adobe Photoshop. And there are many different tools that you can use. If you're following this presentation, you can click on all of these and there are links. So these are just some libraries that you might be using. They're all JavaScript apart from these two here. And you might get started with something like Canvas. And Canvas is what we talked about in the first part of this workshop. Canvas is built in with HTML, and you can use it to draw directly onto your virtual canvas, onto the DOM. Then p5.js, what we talk about today, is a layer on top of Canvas that allows you to do things basically a lot more simply. So we'll get a lot into that. Then you can think of things like GSAP and D3 as helpers. They help you with things like manipulating the DOM data visualization, animations. And then over here, we're not going to talk about these, but they are 3D or WebGL-based libraries. So a little bit more difficult, but they're extremely creative and expressive. Processing, I just put it there for completeness, but processing is Java-based, and it's essentially the Java equivalent of p5.js. So feel free to have a look at this slide later on to figure out what might be some tools that you might find interesting to work with. Now, here are just some slides to show you what I've been up to, but we won't spend too much time on them. But just wanted to show you, I really enjoy working in data and generative art. When it comes to data art, it is things like, for example, this project that I did at work, and I'll just show you the end. So for example, this is one example of data art. And why is it data art? It's because it's still driven by data. So in this case, this is the contest in Europe called Eurovision. Hopefully you've heard of it. And you can click on each country and see all of their songs that they've entered. So this is driven by data, and you can see Spotify metrics of these songs. And you can play with it, but it's not data visualization as such. It's data art because ultimately it doesn't necessarily intend to inform. It's more, it intends to be interesting. It intends to engage the user who's looking at it. Another example of this is this timeline of anime, which I built as a personal project, where each of these bubbles represents one anime over the years. And again, it is data art because it's just an artful representation of data. And then some generative sketches. So a small example, just some sketches I've been playing with. This one was built in 3JS and with shaders. So these are quite simple and things that you can get started with pretty quickly. And an example of just something which I don't even know how to classify. This is done in 3JS, and it's my best attempt of drawing the paths from Attack on Titan, if anyone has hopefully seen that. Okay, so these are just some examples of the kind of work that I have been getting into. And here I've got some examples about the types of projects that we're going to be talking about today. And these projects are less on the data art, and they're more on the generative art side. So first of all, I want to tell you how you can find more of these projects. One way is to look on X. You can look at hashtags like these ones. Or you can also go to, for example, open processing, and we'll get into that a lot more in a second. And here are just some examples of people. You can have a look at all of them by clicking on them, and you see who made them as well if you want to follow these people. But all of the examples that I've linked are examples of sketches which have been done entirely in code, usually P5, sometimes other libraries. I really love this one. And you can see just from the examples that I've selected, there's a lot of diversity of what you can make. You can make, things like this, like generative scenery. You can make things more like this, which look more like organic shapes or more mathematical shapes. You can make really cool animations. And all of this, what unifies all of these different types of projects is the generative aspect. And what that means is usually it means that every time you open a sketch, every time you run it, you might get something slightly different. And the reason is because the whole meaning of generative, the whole purpose of it is that you are generating something based on something. And that something could be randomness or pseudo-randomness, or it could be data, in the case of data art, for example. So lots of really cool examples. lots of things you can do. There's a different level of difficulty. For example, this one is just driven by code and math equations. This one I really like. So please feel free to have a play with the ones that I've selected and also find ones that you like. And the really cool thing about creative coding, about generative art, about p5.js is that there's so many different things you can do. There's not one specific type of application that you have to stick to. And data art, I'm going to skip this section, but I encourage you to have a look at these examples later on if you're interested. So data art, I'd say it's adjacent to generative art. But usually instead of being driven by some random function or by randomness, it's driven by data. So these are also the kinds of projects that I was showing you before that I've worked on. So this was my very quick presentation, and we're going to spend the rest of the time coding. So I think I'll just take a pause for just a second to see if there are any questions. And if not, we're going to get right into the code.
So if you have a question, please drop a message on the chat box. Thank you.
And if you think of something later on also related to that, you can ask as well. Don't worry. But if anyone is thinking about any question they have while we're doing that, I would like to introduce you to open processing. So open processing is, let's go to Discover. If you don't have an account, you can make a free account right now if you want, but you don't have to have one to follow along. But I think that open processing is really cool because I only started using it actually this month. But it's really cool because it allows you not only to create P5 sketches immediately in the browser without having to do anything locally. It also gives you a community of people and you can see their sketches as long as they've opened them, which I think most people do. You can see so many different sketches here and you can click on them, you can play with them, and you can even see the code behind them. So that is a really good way to get inspired and to start learning. So if you click on code, you can usually see the code behind them. And that's what we are going to be using. And here, if you are following this presentation, if you click on part 2, it will take you to the first part, so the sketch that we're going to be using. And also maybe, yeah, I think Cherry has shared this as well. So this first sketch, what we're going to do is we're going to cover all of the basics of p5.js, and we're going to be going pretty quickly. So if you would like to code along with me, you can do that. So you can, whether or not you have an account, if you don't have an account, you won't be able to save your sketch. If you do have an account, you can save your sketch. But either way, you will be able to code along with me if you want. And the way you can do that is, so open this page, this tutorial, and this is what I'm going to do as well. Here in the right-hand side corner, there is a little fork button. If you click that and you click fork, I'm going to just give it a work in progress name, and I'm going to click submit. And now I have a fork of this project, which means that I won't be modifying the original project. So I can keep that exactly as it is, and I'll be modifying this one. And you can do the same if you want to follow along with me. But also, the way that this project is structured is structured as a tutorial, which means that here you can click back and forth and you see that you have slides, and each of the slides has text and it's got code associated to it, which means that each slide will have one sketch and one concept that we cover. So you can have a read through all the notes and all the links, and there's some supplementary links to videos and so on that you can watch if you're interested. So with all of that explanation out of the way, I'm going to just zoom in a little bit so you can all see, and I'm going to get started. Okay, any questions so far? Anyone having trouble setting up? Yeah, just let me know in the chat. Okay, so the first thing that I want to start is I'm going to take a step back and talk about P5, and I'm going to go to the website. It's p5 or p5js.org. Let's go to the website. And if you go to p5.js, you'll be greeted with this starting screen. And here on the left, you can see get started, reference, etc. You can click on teach examples. Today, we're going to focus on the reference. Now, p5.js is a library that was built on top of Canvas. And Canvas is the native functionality of HTML Canvas, of HTML. And I'm just going to show you this. Sorry, let me just show you this quickly. So with Canvas, what you can do is you can draw shapes on the screen pixel by pixel, or in fact, you can manipulate the pixels in the canvas on the screen. That's the idea. And last time we talked extensively about Canvas and how you can use Canvas to start drawing shapes on the screen. So if you click on this first link here, you can go and review this material and things you can draw, like simple shapes. Here we drew some simple shapes. We made a really simple generative sketch with triangles and another one with circles. And then we talked about how you can create more complex shapes like this and how you can start animating them. So for example, with GSAP, you can animate shapes like this. So that's the idea of Canvas. You can draw things on a virtual canvas, pixel by pixel. Now, p5.js does exactly the same, but it provides you with a lot of useful functionality. Yeah, so I'm just looking at the chat a little bit. I'll answer this in just a second. So with p5.js, you can do the same thing that Canvas can do, but it provides you a lot of useful functionality where, for example, it's a lot easier to draw shapes. It's a lot easier to manipulate the DOM. It's a lot easier to have events. So the event functionality of p5.js is extremely helpful. And also it's a lot easier to animate, and it's got a bunch of other functionality, and it's also got a whole community around it, which means that you can find many, many examples to work with. So this is why we're talking about p5.js after we talk about Canvas. Now, just to quickly answer a question. So what are the best use cases for 3.js and p5.js? I would say the difference is there is overlap. The difference is 3.js you use if you want to work in 3D. So if you want to have 3D shapes and yeah, just maybe import models from Blender or something. With p5.js, you mostly be working with just 2D. Although p5.js does have some functionality for 3D. If you go to here, you see there's actually you can use some 3D WebGL-based 3D with p5.js, but it can be more limited. So I would say use 3.js if you're building like an entire 3D world, or you want to import some models from Blender, have really complicated materials, etc., etc. So there is overlap, but it kind of I would normally use 3.js for 3D. So let's get started on how to use p5.js. The first thing I want to show you is what you get when you start a new sketch. So what you get when you start a new sketch with p5.js will look kind of like this, for example. So you might have something in draw, but let's start here. If I run the sketch, clicking on the play button, you just see an empty gray screen. So let's discuss what these two functions do. This function setup and this function draw, they come from p5. Other things such as create canvas, window width, window height, background, they also come from p5. And if this is your first time working in this kind of environment, it might be a little bit confusing to remember which keywords belong to p5, but you get used to it very quickly. And the reason why we don't need to write something like p5 dot, p5 dot, etc., is because the p5 library has been imported globally and it's available for use when you use environments such as open processing or the p5 web editor. Let me just show you the p5 web editor, very similar situation. If I open it and start a new sketch, you see you've got this setup function, this draw function. So that's just something to keep in mind. These functions and these named variables, they come from p5. Now, the setup function, you need to create a canvas unless you already have one defined, but this is the more usual route. So you're just telling p5, create a canvas, and here you tell it the width and the height of the canvas. Now you can give it numbers like 400, 300, and now we have a canvas of width 400 and height 300. Often you might want to tell it take up the entire width and height of the viewport in which case you tell it to use the window width and window height. And again, these variables, they're just provided by P5. It's very convenient that way. So now you've created your canvas, and your canvas is where you're going to draw your sketch. And here we just say, you don't have to do this, but you can set a background. And the background we talk about more, but the background is just going to be a color value. Say, for example, let's change it to pink. This would be something you can do, and now the entire background is really pink. And that's all we've done for now. We've just set up our canvas, we've given it background. You can have a read about setup here. If you click on this link, it'll take you to a documentation and you see what setup does. But essentially, usually it is the first thing you do to set up your sketch. Now, on the other hand, the draw function, let's just say I want to draw a circle. Now, the way you draw a circle is you say circle, you give it the X and Y position of the center of the circle, and you give it the diameter of the circle. So let's say the circle is going to be positioned at 300, 300, and it's going to have a diameter of 100. Now, if I click this, you're going to see a circle, which by default is going to be white with black stroke. I'm going to change this later. And the thing is, though, the draw function, it's not just going to draw the circle once, it is going to draw the circle again and again and again at 60 frames per second by default. So your draw function is, you can think of it as kind of the equivalent to what we did last time with Canvas with request animation frame. But this just makes your life a lot easier because it's just provided for you straight out of the box. You don't need to think about calling it again or anything. It's just there for you. And you know that everything which is inside of the draw function, so everything I write here is going to be executed at 60 frames per second. If you want to change that, you can say frame rate. Let's say, for example, I want it to be 10 frames per second. I say frame rate 10. Now, if I run this, you don't really see any animation happening. And the reason is because we're just drawing the same circle over and over again on top of itself. If we want to actually see an animation, let's see what we can do. So instead of hard coding a value 300, I'll give it a value of CX. And I'm going to start this value outside of the draw function. I'm going to initialize it to 0. And then inside of the draw function, after I've drawn the circle, I'm going to say CX is equal to CX plus 10, which, by the way, you can shorten to CX plus equals to 10. So now what is happening is the first time CX is 0. We draw a circle at position 0, 300, diameter 10, and then we increment CX to 10. And now the draw function is called again, because remember, it is being called at 10 frames per second, again and again and again until I tell it to stop, which I haven't told it to stop, so it's going to go on forever. And then CX is going to get incremented, and then we draw the circle at the new position. And then CX get incremented, we draw a circle at the new CX position. So if I run this sketch, you're going to see a circle being drawn at the new CX position, 10 frames per second. And that kind of looks like animation, but not exactly, right? So what we actually want to see is just the circle currently and not all of the previous iteration of the circle. So what we need to do, it's a bit of a hack, but essentially we just copy paste the background at the beginning of the draw loop. And now if I run it, I would just see the latest circle. And the reason for that is if you think about the sequence of execution of the commands, the background is going to be just redrawn. Then you draw the circle at its current position, you increment the position, you redraw the background, you draw the circle, you increment the position. So that creates the illusion of animation. Now, this is not a P5 specific concept. This is how you do animation in general when you use something like this. But yeah, the P5 specific concept is the existence of the draw function and the fact that the draw function will run at whatever frames per second. So this is already, you know, quite a lot about P5 and how it works. I would just briefly mention that in addition to set up and draw, there is one more function like this, which is called preload. And you can read the documentation, but preload, if you write preload at all, if it's not there, nothing's going to happen. If you include preload, it will run before even setup runs. So it will run before everything else runs, and it has to finish running before everything else starts running. So you might use it for things like preloading images or data, which you need for your later sketches. Okay, so this is kind of the basic. We've covered a few different things, but we're going to start exploring the P5 API. Now, this bit, it's a little bit more boring, but we do need to get through it. Let's have a look at this sketch. So this sketch, we just have a bunch of random shapes on the screen. And what I want to do is I want to show you what exists in P5, and we're just going to do a couple of shapes together, and also talk about styles. Okay, I'm going to comment out everything. And if I do that, we're just going to get an empty, very pink screen. And in P5, there are various different shapes, just like in Canvas, but you have a few more. So we have circle, line, rect, square, point, triangle, ellipse. I might have missed something. And if you click on any of these, it will take you to the documentation, which is really good. It always has examples. So I encourage you to have a look at all of these. And the ones that we don't talk about now, just try to work with them, try to play with them, try to create something, because this is how this gets interesting. You don't want to just be learning a bunch of stuff and not getting to use it. You want to try to use it, try to break it, try to see how much you can change it and what you can make it do. But let's do one together. So remember we did the circle. Now the circle takes x, y, and diameter, and I'm going to show you one more thing. So if I do width divided by 2, height divided by 2, and say diameter of 100, I'm going to get a circle which is positioned right in the middle of the screen. Now this width divided by 2 and height divided by 2, they're again conveniently provided for us by P5, and they correspond to the width and the height of the canvas as we created it and set up. So these are variables that you can use anywhere inside of the draw function, inside of the setup function, and are very convenient when you need to center things. So let's start styling this circle. So in order to give it a fill, you just call the function fill. Let's say, for example, I want to make it blue. I can say fill blue like this, and now it is blue. And let's say I want to give it no stroke. I don't want it to have a stroke. The keyword for that is just no stroke. And now it doesn't have a stroke. Now, let's take a second to talk about the fill function. So in p5.js, anything that has to do with color, so that includes the following: background, color, fill, stroke. Any of these functions can take any number of ways in which you can represent color. So let's have a look at the documentation very quickly. It is very extensive. I encourage you to have a look. It will tell you all the things you can do. So you can give it 3 values, in which case it's interpreted as red, green, and blue values between 0 and 255. You can give it also 4 values for red, green, and blue, red, green, blue, and alpha, in which case the alpha is also between 0 and 255. It's the opacity. You can give it a named CSS variable like red, green, blue, magenta, etc. You can give it a hex color like this. You can give it a string of RGB. And other things. You can give it HSL, HSB, so it's extremely versatile. And the good thing is that the p5.js API is quite consistent, so you can do the same thing for any of these ones, any of these functions which represent color in some way. So just to give you another example, let's do a rectangle next. So the API for rectangle is you write rect, and you give it the position of the top left-hand side corner. So let's say we want it to be positioned at x of 0 and y of 200. Then you give it width and height. Let's say the width is going to be 400 and the height is going to be 300. And if I just run this, we're going to get this blue rectangle. The reason why it's blue is because the last color that we set was blue. If we want to change this, we need to set a new color. So let's say the fill is going to be, I'm going to use the RGB convention. Let's say the red is going to be 0, the green is going to be 200, and the blue is going to be 255. And now you get this nice sky blue colored rectangle. If I wanted to give it a different stroke, the command for this would be stroke. It takes the same values. So say, for example, I want a yellow stroke, I can say yellow. And if I run this, you see it's got a very thin yellow stroke. If you want the stroke to be thicker, you can control this with stroke weight. Say, for example, I give it a stroke weight of 5, and now it is quite thick and you can see it. So we're not going to go through all of the other shapes because the idea is the same and they're fairly straightforward. If you have a look at the API, you'll see what arguments you need to give them in order to see them on the screen. So I'm just going to take a second because I can see there's a question. Okay, so that's a good question. I'll go back to the previous slide for a second. And the question is, when adding background before circle, so I'm guessing it's this line, are we adding a new layer to the canvas each time? Are we clearing and starting over each iteration frame? So yes and no is the answer. When we do this, we are kind of adding a new layer to the canvas. So it's more truthful to say that. So if you think about drawing on paper, it'll be like, okay, I drew a background, I drew a circle, and then I drew the background on top of that. That's kind of what we're doing. But what's happening in the DOM is we always have one canvas. It's not like we're putting more and more shapes on top of it. It's always just one canvas element. So it really doesn't matter if you do background or if you do clear in this case. How can we add a fade in effect when the shape is drawn for the first time? So that's a little bit more complicated. You might need to do something. I'm not going to show you now just because of time, but you might need to do something like do say, for example, the fill is going to be, say, 200, some kind of pink color. And then say, for example, the alpha value, we're going to start with, let's say A. Okay, maybe I'm going to do this. So let's say A is equal to 0. So we start with alpha value of 0, and then at every iteration we say A plus equals 1, for example, and I'll see what happens. So see how it's fading in very, very slowly. So that's a very simple way to do this. There are more complicated ways you can do this. So let me increase that to 10. So now it happens a little bit quicker. Yeah, so that's kind of like one way you can do this. So start with opacity 0 and then increment the opacity at every frame rate. But there are more complex ways and better ways to do this. Okay, cool. I'm really glad people are asking such good questions. So we're going to do something together. We're going to make this very simple drawing program. We'll make it better than this. But what we've got here is, as I move my mouse, I can start very badly drawing a house or whatever, some kind of shape. So let's try to build basically a very simple Paint, Microsoft Paint program. I'm going to delete all of this. So now, again, we're starting from a blank canvas. I forgot to tell you, but when you give just one value to functions such as background, color, fill, it will be interpreted as being the same value for the red, green, and blue channel, which means that you'll get a gray value. Now, let's draw a circle again, our favorite circle. Let's put the circle at, it doesn't matter, position 100, 100, diameter 50. Let's run this, we just have our circle. Now, I want my circle to be drawn where my mouse is, okay? So right now it's just drawn once. I want it to be drawn where my mouse is. P5 provides us with mouse X and mouse Y. And these values will dynamically update every time that you move your mouse. And because we are drawing the circle inside of the draw loop, and this executes at 60 frames per second, every time that I move my mouse, I'm going to draw a circle at that mouse position. So, and this is what we get. Now, if I move my mouse really quickly, this is why you get this jerky movement. And it's because the number of times that the draw function is executed can't keep up with the speed at which I'm moving my mouse. So that's why you get this. And I'm going to say this has no stroke so that we can see just the white bits. So that looks a bit more like we're drawing something. And this is not perfect, again, because if I move too fast, you see circles, and we don't want to see circles. So I'm just going to quickly uncomment this to show you something a little bit more sophisticated. Let's comment this out. So let me show you what it does. So now we have a continuous line, which is much better because, oops, excuse me, because you can actually start drawing something that actually looks continuous, which is nice. And the only thing I've really changed is here's just a bunch of styles. So we talked about stroke, we talked about stroke weight, stroke join and stroke cap just mean that just things that you can do to the join and the cap of your line. And now here what we've done is we've created a line. So this is one of the P5 shapes. A line takes in the X coordinate, the Y coordinate of the first point of the line. and the x coordinate and the y coordinate of the second point, the end point of the line, and then it draws a line between these 2 points. Now, we saw mouse x and mouse y, these are built in, but p5 also provides you with p mouse x and p mouse y, which are the previous value of mouse x and mouse y. So if you keep drawing a line between the previous value of mouse x and mouse y and the current value of mouse x and mouse y, you always have a continuous line. Like this. Okay, I don't want to spend too much time on this, but please do have a look at this example until it kind of makes sense, because it helps you kind of wrap your head around when things happen and how the draw loop works. So I'll move on to the next one and I'll have a look at the questions. How to draw only one quick, another really good question. I think we have an example coming up with that, so I will very briefly touch on that too. Okay, perfect. So let's do our first, not very beautiful, but nevertheless real generative sketch. So this is what we're going to do. We're going to have one circle appear anywhere on the screen, and it's going to have a random fill and a random radius. And we're going to do this together, and we're going to learn a few things along the way. So let's comment this out. And again, we're starting with a gray canvas. The only thing I've done is I've reduced the frame rate. The only reason for that is so you can see things happen, especially as I'm sharing my screen. Now, what we're going to do is let's start by drawing a circle. Let's draw it at width divided by 2, height divided by 2, and let's give it a diameter of 50. So we just have a circle in the middle. Now, I'm going to show you another really, really useful function from p5, which is called random. So instead of drawing this at width divided by 2, I'm going to draw this at random. And random, if you just type this just on its own, is going to return to you a value between 0 and 1. But I want a value between 0 and the width of the screen so that I can draw a circle anywhere in the width of the screen. Now, the width of the screen, we know that it is just width, and I want to go between 0 and width. Let's see what happens. So now we're just drawing one circle at a random position somewhere on the screen, but only on the width. So let's do the same thing for the height. It's exactly the same thing. So we're going to draw it at random, 0 to height. And now we're getting a random circle anywhere on the screen. Again, this random function, because it always returns you a random value, we haven't seeded it. It always gives you a random value. Every time the draw loop is executed, it will give you a different random value. And it will give you a different random value between 0 and width and a different random value between 0 and height. And this is how you get this result of a new circle being drawn at a new random position every time that the draw loop executes, which is really fun. Now, one thing you can do is when your value goes between 0 and anything, you can remove the 0. So this is also interpreted as a 0 to width, 0 to height. And we're also going to do a random diameter. So same situation, but now we don't want it to be 0. We want it to be at least 20 and at most 50. Let's have a look. So now every circle that is drawn has a random diameter between 0 and 20. Between 20 and 50. And let's add even more randomness. Remember the fill function, which takes a red, green, and blue value. If I say, for example, this is just going to give me a blue, green value like this. But now I want to vary this. Every circle needs to have a random green, random blue, random red value. And again, we can do the same thing. So random. And now we're going between 0 and 255 because that's what the values for red, green, and blue are. Again, because we start at 0, we can delete that. And I'm going to do this for the red value, the green value, and the blue value, which means that all of the values of the fill function are going to be random. And if I draw this, we pretty much have our final sketch. Okay, so I'm just very briefly going to show you something. So let's say, for example, function, let me see which one I used before. So let's do mouse pressed. So function mouse pressed. So let's say when mouse is pressed, I want to draw a circle at position mouse X, mouse Y, radius of 100. Let's just remove this for a second. Just want to show very briefly for your question, but now if I click, I'm going to be drawing circles at every position where I click. So this is how you can do that. But we'll get into this in a second. Okay, one last thing I wanted to show you. Let's delete some of that and let's uncomment all of this. So this is what we did together. We created the random circles. And I also want this sketch to stop eventually. And how can I do this? If I don't do anything, the draw function is going to keep going on forever. And eventually we get a very densely packed circles in the screen. But I don't want that. I want this to stop eventually. And we can use this type of logic. So frame count is provided by p5. And frame count just keeps track of pretty much how many times this draw loop has been executed. And loop and no loop, again, these are functions. You can have a look at the documentation provided by p5. Loop means loop, so execute a draw function. No loop means stop executing the draw function. So if I say this, that means if the frame count exceeds 200, stop looping. So the draw function is going to stop executing. So let me show you. We're going to let it run for a while. So it's running, the draw loop's running. It's generating new circles, and after it's executed 200 times, eventually it is going to stop. I'm going to get some water in that time. Okay, it stopped now. And now it's not going to continue, which generally it's probably a good idea to have a condition like that, especially if you have a draw function that does something different every time, because you don't want this to run forever. Eventually it will crash your browser maybe. So that's very useful to know about. Okay, now the next part is something that I'm just going to talk you through very briefly, and I'm going to let you read about it on your own just because it's a little bit long and we have a lot of material to go through. But let me show you what I've got. So this is very similar to what we had before. It's just the colors are different. Now, what I've got is when I hover over one of these bubbles, it becomes purple. So I hope you can see this. And only the bubble that I've hovered over becomes purple. Now, this is actually non-trivial. This is not obvious. And the reason for that is, let me show you this again. So inspect, let's see. In my inspector, hopefully you can see this. See how we've got this canvas element. This canvas element we've been talking about this whole time is just an HTML5 element. And there's nothing in between. There's nothing inside of it. So there's no way you can tell it, give me this specific shape. And the reason is because this shape is just pixels on the canvas. It's not a DOM element like you would have with SVG. If this was SVG, this would be a circle shape and it will be in the DOM and it has an X and Y position and you can easily give it an event listener when you're listening for hover events, for click events. We can't do that in Canvas. So it's not obvious. It's not provided to you by default. So you need to do some maths on your own. But p5 provides you a lot of really useful functionality for that. So if you are looking at the sketch later on, have a look at the second tab called bubble. Here we have a class which constructs a single bubble, so one of these shapes that you see. And it will just position it at whatever XY position you give it, whatever fill you give it, whatever radius you give it, and it will just draw the circle. But it also provides this kind of functionality. And this functionality checks if this bubble has been hovered over with your mouse. And if you have a bubble, which is a circle, it's actually pretty straightforward to check if it's been hovered. And this is how we do this. The dist function comes from p5.js, and it will give you the distance between the first two parameters of the x and y of the first point, and the second x and y of the x and y of the second point. So it will provide you the distance between 2 points. And what do we want? Just let's think about this. We want the distance between, let's take this circle. We want the distance between my current mouse position and the center of the circle to be less than the radius of the circle. This is the radius of the circle. And if that is the case, then that means that I am inside of the circle. If that is not the case, it means I'm outside of the circle. That is the basic idea. And this is exactly what this piece of code is checking. It's checking, is this distance less than or equal to the radius of the circle? If it is, we say yes, it has been hovered, we return true. Else we say no, it hasn't been hovered. And then inside of your P5 code, you can use this mouse press event. You can use this mouse moved event. This mouse moved event is provided to you by P5, and it will keep track of the movement of your mouse on the entire canvas. So you're saying, okay, I'm moving my mouse, and let's check if my current mouse position is inside of any of the bubbles. And if it is, we're going to change its fill to purple. If it isn't, we can change its fill to black. You can do anything. You're just checking the condition, is it inside or outside? So I appreciate this was a little bit quick, but I just wanted to make you aware that this is how people go about checking for things such as events, and whether you've clicked, whether you've hovered on one of your shapes. So this is how you kind of go about it. So I just want you to be familiar with the idea, and then you can read up more about it. And this was the last bit about just the basic Canvas, the basic P5 API. And next we're going to talk about Perlin noise. We'll spend about 10 minutes or so. So I appreciate it's going to be really fast, and Perlin noise is not something I don't think you can learn in 5-10 minutes. So I highly encourage you to have a look at the slides later if you're interested in this. And there's some really good coding train videos on Perlin noise, which will hopefully make all of this clear. And again, my purpose for now is just to make you aware that this is something that is very commonly used, and this is something that you can put in your toolbox for to start making generative art, because so far we haven't really made anything all that generative, and now we're going to start incorporating randomness to make things a little bit more interesting. Okay, I can't see any additional questions in the chat, so just 1 second. Okay. Just giving people just 1 second. You can catch your breath, ask any questions if you have any. Then we go into Perlin noise, and then we're going to do the sketch that I showed you at the beginning. Okay, so I will do my best to explain Perlin noise in 10 minutes now. Let's see what happens. Now, remember how we talked about the random function in P5, which is spelled like this. By default, it returns a random value between 0 and 1. If I give it, for example, 10 and 100 as parameters, it will give you a random value between 10 and 100. But this is completely random. I mean, it's not true randomness because that doesn't exist in the computer, but it is as random as you can get. What if we didn't want complete randomness? In fact, what we do want is something that looks a little bit more pleasing, a little bit more uniform. And just to show you one example, my sketches, for example, this fairly simple sketch actually, and these flowers or flower type shapes, the way that they're generated is using Perlin noise, so it uses this sort of pseudo randomness. And what do I mean by that? I mean, with Perlin noise, I'm going to go straight into showing you a plot of 1D Perlin noise. With Perlin noise, what you get is something that looks a bit more like this. And what do I mean by that? So if you imagine your x-axis to be essentially time, and your y-axis to be the value of the Perlin noise that you'll receive from P5, then think about it this way. At every point in time, say, for example, I'm right here. So I'm right here. I get this value, whatever it is. Let's say it's 0.5. I move in time by a small increment. I go to here. I get this value. It's, for example, 0.51. You see how there is a smooth connection between every value that you receive for Perlin noise and the next one and the previous one. This is how 1D Perlin noise works. You get this, it's still random, and you can control how smooth or how jagged it looks. But every value that you receive from Perlin noise is very similar to the previous and the next value that you're going to receive from the Perlin noise. So this is 1D Perlin noise. You can have 1D, 2D, 3D, 4D Perlin noise. We're actually going to talk about 1, 2, and 3D today. And I'm just going to show you 1D Perlin noise. Now, first of all, this is what the sketch looks like. We have a circle which moves very, very slowly to the left and right, but look how it moves smoothly and continuously. And the reason why it's so smooth and continuous is because it uses Perlin noise. So every movement that it makes is similar to its previous movement. And let's do this together. I'm going to remove this piece of code and this piece of code. So everything that you see right now, we've instantiated some variables, but let me call it X actually. They don't do anything for now. So what we see is just the blank screen with the background. Now let's draw our circle, and let's put our circle at a random position on the width, and let's put a height divided by 2, and let's give it a radius of 50. So now a circle is just going to randomly move along the width of the screen. Let's change this random movement to Perlin noise. Now, the way this works is I'm going to define this variable, which you can call whatever you like. I call it the noise. And this is going to be Perlin noise. The function for this is noise. And it's going to be 1D Perlin noise. So it just takes one parameter. I'm going to give it this parameter, x offset. And x offset is just going to be 0. And I'm not going to do anything else. I'm just going to take this and replace it. And also remember, Perlin noise always returns a value between 0 and 1. And you can't give it any parameters like we did with the noise function, with the random function. If you want it to be, for example, a value between 0 and the width, so instead of 0 to 1, you want to go 0 to width, we just need to multiply by width. So let's see what happens. Well, we just see a circle, and every time I refresh, it's going to be at a different position because Perlin noise is seeded every time you refresh, every time you start a new sketch. But it's just going to be at one position. As you can see, it's not moving. And that is exactly what you'd expect to happen because we're not actually traversing this noise function. So remember, we need to think of it as kind of noise values in time. And our time is our x-axis, this x offset. So what I need to do at the end of every loop is I need to start moving this value. So x offset, for example, plus equals 0.1. And if I do this, now you see the circle is moving a little bit more smoothly than before, but it's still quite hectic. Why is that? It's because we're moving quite fast. So 0.1 is relatively a lot in the world of Perlin noise. If I say 0.01, then you see that now the circle is moving a lot more smoothly. And if I keep making this smaller and smaller, then it's going to move even more slowly. So I hope that makes sense. Just to recap, what we're doing is we are taking this Perlin noise value, which initially we start from 0. And at every iteration of the draw loop, we are moving in the x direction by small increments, and that spits out the next value of Perlin noise. I got a request to add noise on the height, so let me just show you how that would work. If I add the same noise, so this actually gets a little bit more complicated, but if I add the same noise on the height times height, think about to yourself what is going to happen if I add the same noise to the height as well. It's smooth, but it's only going to go in the diagonal. And that is because I'm adding the same noise value on the X and the Y position. So there are ways you can do this. And actually that's here in 2 dimensions by using 1D Perlin noise. And I'm going to skip this, but please have a look. It's actually quite a smart way you can do this by just using 1D Perlin noise. And I believe that was the sketch I did, yeah. So now it's moving in the X and Y directions using 1D Perlin noise, but not just on the diagonal, it's actually moving anywhere. So have a look at this trick. But I want to move on just for the sake of time and show you 2D and 3D Perlin noise very quickly. Now, 2D Perlin noise, if you just have a look at this part here, let me say const the noise. So just so it's the same as before. And I say this. Okay, so 2D Perlin noise looks like this. It's exactly the same, except it's got 2 parameters now. And this is what it looks like if we draw it with its pixel values. So now I've got this little sketch where each pixel is colored by the grayscale value equivalent of its Perlin noise at that location. And you see how it looks kind of smooth, right? it looks cloudy but kind of smooth. And that is because with 2D Perlin noise, because we're now working in 2 dimensions, it's not that every pixel needs to be the same as every pixel next to it on the left and the right. Every pixel needs to be the same as all of the pixels around it. So that's what makes it 2D. And to get this effect, what we need is we need an X offset like before, but we also need a Y offset. And let me move this so you can see this more clearly. So let's concentrate on this part right here. And let's see what's going on. So we'll do this for loop together in a moment, but we are looping from X is equal to 0 to the width, and we're looping Y to be equal 0 to the height. So we're traversing the entire canvas that we have. And we're starting with X is equal to 0. Now we want for every X offset, we want to then start the Y offset at 0 as well. And then we increment the Y offset inside of the Y loop. And then we increment the X offset inside of the X loop. Now, if this doesn't make sense initially, try to sketch it on paper. Try to imagine what this for loop is doing, what this nested for loop is doing. But essentially, we're just saying for every X offset, we start the offset, the Y offset again, and then we take the noise at this X offset and this Y offset value. And here we use that noise in order to determine the color of the stroke of a point. So that is 2D Perlin noise. It does always make the same pattern, really good point. Yeah, so if you do that, it will always make the same pattern, but it's not going to make the same pattern. It's always going to be the same pattern within your current session. But if I refresh, see how I actually get different patterns. The same in the loop, that's correct. It's the same in the loop, and we're going to get to 3D Perlin noise, and you see how we can change that. But it's also important to note that it is the same pattern. But when you refresh the sketch, you will get a different pattern. And the reason for this is because the noise function in p5.js, it's kind of seeded differently every time that you start a sketch. So if you want to make sure that you get the exact same pattern all the time, you're going to need to create some kind of seeding, which we're not going to do here. But yeah, you're very much correct that every time that the draw loop execute is going to be the same value. So if you want that to change, the best way you can do this, and really the way you probably should be doing this, is with a 3D Perlin noise. So I'm just going to show you one more example of 2D, and we're going to go to 3D. But in another example is we don't have to draw a grid of pixels. We can draw grids of other shapes. For example, this is how you might use it to generate. You see how we've got these smooth regions, which are darker, and then next to them we have lighter regions. And this is what we're going to do together in a second. Okay, so the more interesting thing is 3D Perlin noise. So let me show you the previous example, but now with 3D Perlin noise. So now the grid is smoothly animating through time. So every time the draw loop executes, it is smoothly moving onto the next pattern. And this is done with 3D Perlin noise. Now, let's think about this. Remember what we did at the very beginning. We had this circle that just moved in a straight line. And the way we had this work is we had to initialize the CX value, so the value of the center. It had to be initialized outside of the draw function and then incremented every time that the draw function is running. This is exactly the same idea. So if you have a look at just this part, let's have a look at this part here. So everything in here, this is pretty much the same as we had before. So we're initializing an X offset, a Y offset, we're looping through the width and height, except we're moving every 10 pixels instead of every 1 pixel. This is what this means. And the only new thing is notice how the noise function has now taken 3 values. So it's got the X offset, the Y offset, and the Z offset. Now, the name Z offset is completely arbitrary. It doesn't mean we're moving in a Z direction. This is not 3D space, it's just 3D noise. When we just go at Z offset by convention. And now this Z offset, we've instantiated to 0 outside of the draw loop. You can put it anywhere you like. You can put it here if you want. It just has to be outside of the draw function. And then we're incrementing it at the end of the draw function. And this is how we can now have a different pattern here every time that the draw function runs. Okay, so I know this is quite a lot to take in. And again, I encourage you to go and read the notes and watch the videos because Perlin noise is something that's extremely useful in a generative art and P5 and whatever else you use for generative art. It's used all over the place and it's got so many interesting ways that you can use it. And you get more and more familiar with that, the more kind of sketches you build. And we are going to do next, we're going to finally build this example. So if you click on part 3, you're going to get to this example. And this example is going to use all the things that we learned, and it's going to use Perlin noise to generate this pattern. So see how it's quite similar to this, but there's some key differences, which is where we're going to like start thinking about how we can use Perlin noise in ways that are a little bit more creative. It's really the beginning of that. So I'm just going to take a moment and see if anyone has any questions. And while I'm doing this, you can open this part 3. And you can do the same thing as what we did before. Just make sure to clone that sketch if you want to keep your work. Okay. I'm not sure entirely understand the question. So the question is, can you attach styles to shapes or you just declare them before? If I understand you correctly, I think you kind of, the way that P5 works, you're not styling shapes in CSS or anything like this. You kind of have to define the style, draw the shape. So you can't draw the shape and then say, by the way, I want my shape to be blue. So it kind of needs to go together, I think, if I understand your question. But I will show you something now, which is hopefully going to be useful for that. Okay, thank you. So I'm going to go, we have about 20 minutes, which is not enough to go through this. So I'm sorry if it's a little bit fast. But I want to show you how to draw this little sketch. So I'm going to go here. Oh, sorry. I'm going to go here and make a copy. So I'm going to fork this. And again, I'm just going to call it work in progress. You can do whatever you like. It's just so that I can keep the original. And what we're going to do here is you see we have this sketch and then we just have this one slide here. And I'm going to create a new slide by clicking this plus button. And this is going to make a copy of all of the code from the previous slide. And I'm also manually going to copy paste this text. And this text is only just to help us stay on track. So this is just the sequence in which I want to do this together with you. And now what we've done is we have a copy of all of the code. So I'm going to go ahead and in the second slide here, I'm going to delete most of it so we can do this together. So let's delete all of this. All of this, basically almost all of the draw function, and I'm going to delete all of this stuff. So we're going to end up with pretty much the usual starting point. I'm going to keep these things for now. Actually, I'm just delete. Okay, so let's have a look. We just have an empty canvas, which has got a background of 0, which is 0, 0, 0, which is black. And that's pretty much it. So we're going to start and we're going to like incrementally build the sketch. And the first thing I want to do is I want to draw a grid of circles, just circles. And I want those circles to be positioned at every 20 pixels. And I want them to be of diameter 20 pixels. So this is what this variable is going to keep track of. Dims, dims is equal to 20. And we also have this dims inner, which is dims -2. This is literally so that we can later on give some padding to our shapes. That's all that this means. So let's go, and what I want to do is, so this is a bit new, but I'm going to say const shapes and instantiate an empty array. And I'm going to, in the setup function, instead of drawing the shapes, I'm just going to fill this array with all of the information about those shapes. So what do I mean? So let's say for let x is equal to 0, x is less than the width, and then x plus equals dims, so every 20 pixels. And let's say the same thing for y. So y is equal to 0, y is less than height, and then y plus equals dims. So it is just a nested loop that makes sure that we're traversing the entire canvas at every 20 pixels. And I'm going to say const shape is equal to, and I'll just create a JavaScript object where the x is going to be the x and the y is going to be the y. And I'm going to give it a radius of, actually, I'll just keep it simple. Let's keep it like this. In JavaScript, if you have the same key and value pairs in an object, you can delete one of them. So you just need this. And then I'm going to say shapes, push, shape. And now we just have an array of x and y values. So these are not actual shapes. I've called it shapes because this will become a useful name afterwards. But all I've done is I've just filled in an array with some x and y coordinates. So if I run this sketch, you're not going to see anything. So let's quickly actually draw something. So one way we can do this is we can say shapes for each shape. I'm going to draw a circle, which is going to be positioned at shape.x, shape.y, and it's going to have a radius of dims, a diameter of dims. So now we should see a grid of circles. This is a very common approach. So you very often want to create all of the information about the shapes that you're going to be drawing. So not just x and y positions, it could be things like colors, etc. You want to create this in some array, and then you want to draw it in the draw loop. And there are reasons why this is useful, which hopefully you're going to start seeing soon. Now, what I want to do is, this is how you really should be doing this, because it's quite straightforward. But what I want to do is I'll do this in a bit of a more complicated way. And the reason for that is just because it's going to be helpful later on when we do Perlin noise. So instead of just looping through the shapes with a for each loop, I'm going to copy paste this code and hopefully get it right the first time. So now I don't want this. So I'm now looping again through the width and height. And for each x and y, I want to find the unique shape in the array of shapes which correspond to this x and y position. So let's say const shape is equal to, and I'm going to use shapes filter. And I'm going to say, let's say D, you can call whatever. So dx, its x position needs to be equal to this x position. And the y position needs to be equal to this y position. And that is going to give us just one shape because there's only one shape at this x and y position. So I can just say 0. So that is now going to give us an object that looks like this. And now I can draw the circle at this shape's x and y position. So let's see, hopefully this will now work the first time. Yeah, so these two methods are exactly equivalent. And I know this looks ugly, but we're going to need this loop for Perlin noise later on. Okay, so now let's make this a little bit more interesting. So instead of circles, I want to draw different shapes. And here I've given you an array of possible shapes, and this is the first place where I really encourage you to experiment and try out different types of shapes and try to change their styles, change how many shapes you have, etc. But for now, I've just defined 4 different shapes. So circle, rectangle, plus, so a plus sign, and a stroke circle. And I want to, first of all, here, is in addition to x and y coordinates, I'm going to add a value called shape. And this value is going to be a random value from here. So random value from here. So random is exactly the same random function that we talked about before. But in P5, when you give it an array of discrete values, it will just randomly pick one of them. So the result of this is going to be one of these things. And now what I want to do is not just draw a circle. I want to say, depending on the shape, I want to draw something else. So very simple example, but let's say if shape.shape, so that is now, this is the shape, and then dot shape will give you this. Sorry, it's a bit confusing, but if shape.shape is equal to circle, then we are going to draw the circle. Else, for now, just for the time being, else we're just going to draw a rectangle. So I'm going to draw a rectangle, which is going to be positioned at shape X, shape Y. It's going to have width of dims and height of dims. And I'm going to use a rect mode of center, which centers the rectangle. So if I do this now, then every time I run this, I'm going to have circles in some positions and rectangles in other positions, and they're going to be different every time because of the random selection. So that's kind of the idea. And now let's extend this idea. So we don't just want to be doing this. This is not that interesting. We want to have a different shape for each of these. And here's where I'm going to do a bit of copy pasting just to save time. But let's have this function called draw shapes. Let me copy all of this. And let's go back here. And I'm going to put this function somewhere outside of the draw function. You can put it up here, or you can put it down here. It doesn't matter. It's just we want to just define a regular JavaScript function, nothing special. So let's quickly have a look at what we've got. So we have this draw shape function, which is going to take the shape, the X and Y position, and it's also going to take a fill color and a stroke color. So we add these in a second. And I want to say, depending on what the shape is, whether it's circle, stroke, circle, rectangle, or plus, I want us to draw a different shape. Now, I'm going to show you this in a second. So let's remove this push and pop. So if it's a circle, it's going to be a filled circle with this color and without any stroke. Then if it's a stroked circle, it's the same situation, but it's also going to have a stroke color. If it's a rectangle, it's going to be a rectangle. We already did this, and we can simplify this code a little bit. So let me just do this, just so it's a little bit easier for you to keep track of later. And then finally, if it's a plus, we're going to, there is no plus function in the API for P5. So instead, have a look at this code. What we are doing is we're just drawing two lines. And one of these lines is horizontal and one is vertical. And we're giving them a stroke. And this is how you can get a plus. Now, this is all we need. There's one more thing I want to show you, which is all the stuff that I deleted. And this is the push and pop. Now, push and pop, these are equivalent to save and restore in Canvas. And what they do is they say, whatever is between push and pop, just keep those styles limited to whatever is inside of push and pop so that they don't bleed over to the other shapes that you don't want them to. And we can't put it outside of the if and else. So before I had them inside of each of these, and that was actually redundant because you're always going to have one thing returned from here. So you can do it this way. So if I just run this now, nothing different is going to happen. And that is because we have just defined the function, but we haven't used it. So let's use it. So I'm going to copy this. And I'm going to put it instead of all of this stuff. Now, what parameters does it need? It needs the shape, but the shape is this kind of stuff. So that in our case is going to be shape.shape. It needs the X and Y value, which we can pass them from here, but let's be consistent. They're going to be the shape's X value and the shape's Y value. We don't have a color and a stroke color, so let's just define those. So color is going to be fill of 255.0, and let's give it a random blue color. So between 0 and 255. And let's do the same for the stroke color to save some time. So this is going to be the stroke color. So think about for a second what you think is going to happen. And let's have a look at the sketch. Oh, and I made a mistake. Object invalid, current inside. It doesn't always give you the most useful errors. So let's have a look. So color, stroke color. I'm just going to copy paste this function again because I know this works and we don't have too much time to debug. So let's see if this will fix it. Draw shapes. No, I'm doing something wrong with the fill. So let's see. I wonder why. So shape.shape, shape.x, shape.y, color, stroke color. Okay, we don't have too much time. I think it's probably a silly mistake. So I'm just gonna copy paste this stuff. Let's see, hopefully that will work because I don't see what is wrong here. Let's delete this. Let's see if that works. This is very bizarre. Let's say the color is white and this is also white. Let's see if that fixes it. Okay, there's something wrong with my definitions of colors. Okay, this is the exact same code, so don't worry too much about what we did. But what I want us to do next is I want us to play with the colors. Okay, so I don't want everything to just be white. So all we've done so far is we've got all the shapes correct. So we have random shapes, but they're all the same color. And this is where I want to start using Perlin noise for the color. And I want to use 3D Perlin noise. So let's start, so we're here now. So let's start by defining the 3D Perlin noise. Hopefully you remember how we did this before, but this is a refresher. We're going to type out everything. So because we're going to animate over time, I'm going to say let z offset is equal to 0. And I'm going to increment z offset by, I think I defined this inc value here, increment value. Okay, increment val. And you can play with this number. So we're going to start with 0.1, but we're going to change this later to see what happens. And then that's why we did this x and y loop, because we want these x and y values in order to start doing our Perlin noise. So let's define, so just as before, we're going to say x offset. We need to instantiate this just before the x loop, remember? So we start from 0. And then for the y offset, just before the y loop, we say y offset. And then where do we increment them? We increment the y offset here inside of the end of the y loop. So I'm going to say y offset plus equals to the same increment value. These can also be different. And the x offset is going to be the same increment value. So we've defined our x, y, and z offsets, and we're incrementing them correctly. So the only thing that we've got left is we need to, let's put it here maybe, we need to define our Perlin noise. I'm going to call it the noise again. And this is going to be Perlin noise at x offset, y offset, and z offset. And if I run this, absolutely nothing is going to happen. And the reason is we've defined our Perlin noise, it exists, it returns a value between 0 and 1, and it's smoothly moving through its noise space at every call of the draw function. And that's great, but it's not actually doing anything. So let's say, for example, I wanted to, the color, let's see if we can do this. Hopefully we can do this. Let's see. I'll just test this and then explain what I did. Yeah, so what I've done here is I've said that the color and the stroke color are going to be the Perlin noise value, but we don't want it to be 0, 1. We want it to be between 0 and 255 to get a grayscale value. So we just multiply by 255, and I do the same thing for the stroke color. So what we're going to get is Perlin noise. So now everything is colored based on Perlin noise, but it's just a grayscale value. And this is where we can start getting a little bit more creative. So let's say that instead of completely continuously moving through the color space, we wanted to move in regions. Let's have a look. So this is our final sketch. So notice how there are regions of colors, and these are very discrete regions of colors. So see, for example, here is another example. And the way to do this, it's actually pretty simple. I'm going to copy paste the code for this, and then I'm going to explain it. So let's just grab this function. And let's put it here. Again, this is just a normal function. Now, this function is going to take the noise value, and it's also going to take a palette, but we haven't defined our palette. We are going to say let palette, and it's nothing here. And inside of setup, we're going to say that palette is equal to random selected colors. So what this does is it's going to select a random palette out of the selected colors, and you can find the selected colors here. So here we have a list of 5 different palettes, and each of them contains 5 colors. So what this is going to do is it's just going to select one of those 5. So one of those 5 arrays. So we have 5 colors. So that's what we've done here. And we need to pass this into this get color and stroke function. Now, don't worry about the stroke for a second. Let's just have a look at the color. So this color value. Now, what we're saying is, this is just a switch statement. You can also do a bit if and else if you want. But we're saying if the noise value, remember, it's between 0 and 1. So what we're saying is, if the noise value is less than 0.2, set the color to the first color inside of the palette. If the noise value is between 0.2 and 0.4, set the color to the second value of the palette, etc., etc. So what we've done is we've discretely split the noise based on its value. And we're saying if it's between these two values, give me a specific color. If it's between these two values, give me a specific color. I do encourage you to refactor actually this function because there's a prettier way you can do this. But that's the idea. We don't want the noise value to interpolate colors. We want it to give us different colors for different regions. And we do the exact same thing for the stroke color, but we make sure that the stroke color is always different to the color. The only reason for that is just to add more visual interest. And this is where you can start to get creative. So see what happens if you have more of these intervals. So maybe you use more colors. See what happens if you use fewer colors. See how you can start playing with the stroke. Try different colors. So these are just 5 color palettes that I like. Here I've provided you with a lot more color palettes, so you can start using these ones instead of these ones. So there is a lot that you can do here. And the final thing I'm going to do is I'm just going to call this function. This function will return color and stroke color. So now let's do this. And we're going to say const. So color and stroke color is equal to what this function returns, and this is going to give us, hopefully, this. So that is the idea. You can see how you have different colors of region, and this kind of pattern is something that you might see in a lot of different places with P5, a lot of different sketches that people try, so it's a fairly basic technique. That is not the only way to do this, but it's one way to do this. And if I refresh every time, it's going to select a different palette. We only have 5 palettes, so they're going to repeat quite a lot. I really, really like this one. And finally, we have absolutely no time left. So I'm just going to copy paste something to show you. So remember we had this tree. And the way that I've done this tree is actually really simple. So let me show you. So at the end, inside of the setup, so I'm still inside of this function. I've just copy pasted the bit of code. And if I run this, hopefully we should see this tree. So what this tree is, it's a clipping mask. And it's really one of the easiest ways you can do a clipping mask. So we define the clipping mask as a path 2D of a clipping path. And then everything here is just some translation and scaling to make sure that it's in the right place. But all we really need is these 2 lines. So this line 26, line 30, line 31, that's all we need. Everything else is just scaling and positioning it. But all we need is we define the clipping path and we say begin path and then we clip. So we just do clip and we pass in the clipping path. And this drawing context thing, this is basically your CTX. So this is equal to CTX. So that is your canvas context. And we need this in this case, just because the path 2D API is not available in P5. So we need the drawing context, which is the CTX. And where did I get this clipping path? If you go to this clipping paths tab, this is the one I'm using here. It's clipping path 1. And this is just an SVG path. So I went to, in this case, the Noun project, which provides free SVGs that you can use. And you can use that SVG to extract those paths. Or if you're familiar with things like Adobe Illustrator, you can create them on your own. And you just need this path. You don't need to do it yourself with code. You just usually get it from some piece of software. And this is an SVG path. And so you literally just need to pass this path into this path 2D and then use it as a clipping path. Now, this was, I realized, a little bit quick and it's a bit more advanced, but it's not a difficult concept. And it's just something I wanted to make you aware that you can use to make your sketches quite a lot more interesting very quickly. And I see there is one question. Can you export P5 Canvas to image, GIF, and video? Yes. So have a look at the documentation. There's some ways you can do this. P5 provides you with some functionality where you can do this. And there are also external libraries. If you Google P5 export to GIF or video, you'll find a few of those. So yeah, that is something you can do. It might not be the best quality, so have a look around what you need. And with this, I'm pretty much at the end, and I'm just going to leave you with thank you so much for your attention. I know this was really quick, but just to reiterate, this was really just to kind of give you an idea of how to get started. So go back to the resources and then some excellent videos. The Coding Train has really good videos on YouTube. Have a look at the p5.js social media. And have a look at Open Processing, also Processing Japan, which I believe let me just show you very quickly. If you go to, oh no, they've changed it. So they used to have a background, which was very similar to, I don't know if it's still there. They had one example of a background, which was very similar to what we did just now. So have a look at these resources. And yeah, you can find me and you can always ask me questions later on. So thank you so much. I know we only have a couple of minutes left. Um, so I'm going to hand
Yes.
over to Thierry. No, thank you so much, everyone.
So thank you so much, Dia, for your fascinating and creative presentation. If anyone has question, like now is the time, like we only have a few more minutes. So today's recording will be chopped, and if all is good, I'll post it on YouTube. For those who join via Meetup, I will share the link in comments section. So once again, a big thank you to everyone for who participated. For those in Tokyo, have a great evening. Uh, you have a question? Okay.
Yeah, no,
And
thank you
I
so much.
believe, yeah, I believe Dia is at lunchtime in London, right?
Yeah.
Yeah, so have a wonderful day.
Thank you so
Well,
much.
thank you, everyone.
Bye
Bye.
bye. Have a good evening.
You too. Bye.